So let's see the question number 21, right, of limits. So question is limit x tends to 0, e raised to x raised to 2 minus cos of x divided by x square.
The 22nd question.
Okay, this is done, right? So
Yes,
let's
sir.
see the question number 22 then. So 22 is limit x tends to 0, x cos of x minus log of 1 plus x divided by x square. So we will apply here L'Hospital rule. L'Hospital rule. So in L'Hospital rule, we differentiate numerator and denominator. Then it will be equal to limit x tends to 0. We will apply here u into v rule for this one. So this is your u,
Okay.
this is your v. So it will be x differentiation of cos is minus of sin x, right? Plus, now I will take cos x, right, outside, and we will differentiate x with respect to dx minus differentiation of log of 1 plus x by dx. And as we know, differentiation of x square by dx will be. So let's differentiate now. So it will be x, and differentiation of this will be cos of minus of sin of x plus cos of x, and differentiation of dx by dx is 1. So it is 1 minus log differentiation is, it is 1 upon. So it will be 1 plus x, and differentiation of 1 plus x will be 0 plus 1, right? And denominator will become, it is power 2, right?
2x.
Coming out, so it will be 2x raised to 2 minus 1, that is 1. So this is the differentiation part. Now put x is equal to 0. Are you getting this 0 by 0 form? Let's see. If you are getting, then again you have to differentiate. We are getting 0 by 0 form. So next, see the next slide. Limit x tends to 0. So it is your minus of x sin of x plus cos of x, right? Minus of 1 plus x by 2x, right? So again we have to differentiate it. So it will be limit x tends to 0. Again here apply u into v rule. Here u into v rule. So it will be minus of x differentiation of sin of x by dx, right? So it will be minus of sin x outside and differentiation of dx by dx plus differentiation of cos is minus sin x, right? So differentiation of cos x will become minus of sin x, and differentiation of minus 1 upon x square will become minus of minus 1 upon 1 plus x ka whole square, right? This is the differentiation of this part. Divided by differentiation of 2x will be 2 and x will be 1. Now put the value of x after differentiation. So it will be minus of x. For sin differentiation is cos of x minus of sin of x. It is 1. Cos differentiation is minus of sin x. So it will be minus of sin x. And it will become 1 plus. So it will be 1 plus x whole square divided by 2. Now put the value of x is equal to 0. Here this will become 0 after putting, and sin 0 is 0, and this is also 0. So it will be 0. So it will become 1 upon 2 only. So your answer is 1 upon 2. Got it?
Yes, sir.
Now we'll apply here L'Hospital rule for this question. So it is limit x tends to 0. Cos differentiation is minus of sin ax, and differentiation of x will be a only, right? Next, in the similar manner, this will become minus of sin x, no, it is b now, and differentiation of bx by, and x square will be 2x. So
Yes.
please arrange this one. So it will be minus of a sine of x plus b sine of bx divided by 2x. Understood?
Yes.
Okay. Hmm. So you can directly get the answer like this one. So suppose I want to arrange this one. So it will be, as we know, limit x tends to 0, sine of x by x is nothing but it is 1. So it is minus of a. So it will be a of x divided by. So I will take 2 here and I will multiply with a and divide with a. So it will become ax and numerator will become a. In the similar manner, this will become b sine of bx divided by 2 and I need here b. So it will be bx and multiply with b, right? So
Yes.
this will be the one and this will be the one, right? This part,
Yes.
it will be multiplied here. So your answer will be minus of a square upon 2 plus b square upon 2. So this is the answer. You can check it out.
शायद आ रहा है.
Okay. So let's see 24. Limit x tends to 0. Question is x cos of x minus sine of x divided by x square into sine of x. So I will use here identities like sine of x by x is nothing but it is 1. So this can be written as, so it is x cos of x minus of sine of x. So I will multiply numerator by x and denominator by x. So it will be x cube into sine of x. Right. So this will become nothing. It is will be 1. So limit x tends to 0. So let's see. So remaining is limit x tends to 0. Then your equation is remaining is x cos of x, right, minus of sine of x divided by x cube. Now apply L'Hospital rule, right? So it will be u into v rule. So it will be x cos
Minus
differentiation is minus of sine of x.
9x.
Again, now take cos x outside and x will be 1 and sine differentiation is cos of x divided by 3x
3x.
square, right? So this is getting cancelled, this and this, right? So remaining is
Yes.
minus of x sine of x upon 3x square. So 1x and 1x will get cancelled. Remaining part is minus sine of x by x into 1 upon 3. So it will be 1, right? So your answer will be
Yes.
minus 1 upon
Minus
3.
1 by 3.
So please write it down. Now let's see 25 question number. So it is limit x tends to 0, 1 upon x minus log of 1 plus x divided by x square, right? So take the LCM now, then apply L'Hospital rule. So LCM is x square, right? So it will be x minus of log of 1 plus x. Why we have taken limit here? See, I will show you the proof. When we put x is equal to 0, so 1 upon 0 will be infinity. So it is nothing but infinity minus infinity form, right? Put 1 upon 0. So 1 upon 0 is nothing but infinity and it is also getting infinity. Now after taking the LCM, it has become 0 by 0 form. So now you can apply L'Hospital rule. L'Hospital rule. So it will be limit x tends to 0. So it will be 1 minus log differentiation is 1 upon x and x square differentiation is 2x. Now put the value of x. So it will be 1 minus 1 upon 1 plus 0 divided by 2 into 0. Right. So again we have to differentiate. Right. We are getting 0 by 0. So again differentiate. Right. So what we'll get? So 1 will be 0 and minus of 1 upon x square will become plus 1 plus x square, and denominator will become 2 into 1. So your answer is 1 upon 1 plus x whole square divided by 2. After putting, you will get 1 upon 2 answer. Right? Got the answer?
Yes. Yes.
Now see the question number 26. So it is limit x tends to 0, y minus tan inverse of y divided by y minus sine of y. So after putting x is equal to 0, so it is given in y form, right? So you have to take here y tends to 0 then, right?
Yes.
After applying L'Hospital rule, you will get y differentiation is 1 and tan inverse it will be 1 plus y square. So right here, when y equal to tan inverse of x, its differentiation is nothing but 1 plus x square. So instead of x here, y is there. So I have used minus 1 upon y square divided by y differentiation is 1 and sine is nothing but it is become cos of y, right?
Yes.
Now take the LCM. So LCM will be 1 plus y square minus 1 divided by 1 plus y square into 1 minus cos of y, right? So now put y tends to 0. This and this will get cancelled. So remaining is nothing but y square, right? So it is 1 upon 1 plus y square, and here y square upon 1 minus cos of y. So again it is in the form of what?
0.
0 by 0 form. Again differentiate it, no?
Yes.
Okay. So why we have separated here? For the limit application, for limit y tends to 0. Here again apply here limit y tends to 0. So you will get like this. Put here y equal to 0, then it will be 1 plus 0. And limit x tends to y tends to 0. So it will be nothing but it will be 2y. Right, y square differentiation is 2y and 1 is 0 and cos is minus of sine. So it will become plus of sine of y. So this will become 1 now. So your answer will be 2, right? So 2 by 1
Yes.
is nothing but it is 2. Now 27 question number is limit x tends to 0 plus limit x tends to 0 plus log of sine of 2x into sine of x. Right. So I will use here the property. So I will change of base I will use. So it will be log of sine of x by log of sine of 2x. So this property is used here. Now take the apply L'Hospital rule now. L'Hospital rule. So it will be nothing but log differentiation is 1 upon. So it is 1 upon sine of x. And sine of x differentiation is cos of x. In the similar manner, log of sine 2x will become 1 upon sine of 2x. And sine 2x will be cos of 2x. Now arrange it. So it will be cos of x divided by sine of x into cos of 2x divided by sine of 2x, right? So now see, for the log applying limit, so it will become directly 1 now. Limit is x tends to 0. Because we know the identity limit x tends to 0, cos of x is directly 1, right?
Yes.
And for the others, we have to arrange, right? So remaining is limit x tends to 0, sine of x upon upper part is 2x now. So it is sine of 2x.
2x.
2x divided by sine of x. So I need here 2x and x, right? So I will arrange here. So it is sine of 2x. So I need here 2x. And for the sine of x, I need here x. So what we have done, divide by 2. So I need to multiply with 2, right? Then it will become
Yes.
1 and this will become. So your answer will be 2. Right?
Yes, sir.
See here, we have done that mistake. This differentiation is nothing but it is 1 upon sine of 2x, right? And sine 2x differentiation is cos 2x, right? So again, we have to difference 2x now. So it will be 2, right? So in denominator already 2 is there. So no need to divide. So when we are multiplying with 2, so it is 2 already. So it will be coming out to be 1 then, right? So please mind the modification. So let's see the 28. So it is limit x tends to 0. Limit x tends to 0, 1 upon x square minus of cot of x upon x. So it is nothing but infinity minus infinity form. So I will take the LCM, then it will become x square. Here it will be 1 minus of x cot of x. Right. So again we will differentiate. So you can also directly differentiate, or you can take the, you have to convert into tan also. So cot of x can be written as 1 upon tan of x. So it can be limit of x tends to 0. So it will become 1 minus x upon tan of x divided by x square. So take the LCM, then it will be tan of x minus of x divided by tan of x into x square, right? So now differentiate it, or you can take like this also. This can be written is in the this form also, tan x of tan x minus x by, here I am taking x square, right? And here 1 upon tan x. So as we know, limit tan of x by x is nothing but it is 1 when x tends to 0. So I will use this identities here. So you can see here it needs x. So I will multiply with x and divide with x. So this will become again now 1. So remaining is nothing but remaining is tan of x minus of x divided by x cube. Limit x tends to 0. So again differentiate it now. So tan will become sec square x and x will be 1 and x cube will be nothing but it is 3x square. Right.
Yes.
And we know the identities like sec square x minus tan square x is nothing but it is 1. So it is sec square x minus 1 is equal to nothing but equal to
Tan square.
tan square x. So use these identities here. So it will become tan square x upon 3x square. And as we know, tan of x upon x is nothing but it is 1. So it will be 1 upon 3 into 1. So answer is 1 upon 3. Understood?
Yes, sir.
Okay.